Class 7, all of you studied it. Memorized it, passed your exam, you forgot. I'll tell you what you memorized. What is heat? Heat is a form of energy. Remember, all of you memorized? What is heat? Heat is a form of energy. What is heat? Heat is a form of energy. Exam comes, you write the answer, you come to class 8, you forget it. And this is most normal, this is more natural. So let us look at heat. How do you measure heat? Not thermometer, temperature. Okay. Now, can you tell me what is your body's temperature roughly right now? Do you have fever?
No, I don't.
Okay, you don't have fever. So, what is your temperature, body temperature? Roughly.
Normal.
What is normal? What number? Give me a number. What is normal body temperature? Who can say?
37 degrees Celsius.
37 degrees Celsius, and in Fahrenheit,
98.
something like 98. Now you tell me, why do we have two scales? You look at a thermometer. On this side is Celsius, on this side is Fahrenheit. Do you think human beings both are measuring heat? Do you think people made two different scales just to make you work hard? Remember that Fahrenheit to Celsius equation you have to remember? Huh? So something by something plus something. Why? Yeah, but why do we have to do that? Why couldn't humans just have one scale? Then your life would have been easier. Have you thought about it? Why is and why don't they match? So I'll start by saying how the two scales were formed. When you want to make a scale, meaning you need a zero. See, when we say ice temperature of ice or the melting point of water is 0. That 0 is arbitrary. Somebody said, from today, let's call this 0, right? When somebody says melting point, boiling point of water is 100, somebody said it must be 100. So when we make a scale, when a new scale is made, suppose you are a scientist and there is no temperature scale and you're trying to make a new scale, what do you need? You need 2 points, one upper, one lower. You call the upper 100, you call the lower 0. So one scale, and this is the centigrade or Celsius scale, started like this. The Celsius scale came later. They said there was an upper limit, there was a lower limit. The upper limit was boiling of water, because everybody knows, okay, wherever I go, water boils at the same temperature. But you know, if you go up a mountain, what happens to boiling point of water? Had anybody been up in a mountain? Not even Ayodhya Pahad? Do you know, maybe you should once try to go to, have you heard of Darjeeling?
Yes.
Has anyone been there?
Yes.
Some?
Yes.
You've been to Darjeeling? Did you ride a horse? No. So if you go up, boiling point of water will act. Yes. But if you're on the plane, whether you're in America or Thailand or Japan or India, boiling point of water is same. So the upper is the boiling point of water, okay? Boiling point of H2O. And the lower is the freezing point FP of water. And this, we call it 0. And this we call it 100. And then we divide this by 100 little degrees, okay? So what we know therefore is how Celsius scale was formed. We needed a lower number, we needed an upper number. Upper number was, everybody agreed it will be the boiling point of water. Lower number, everybody agreed it will be the freezing point of water. That's how Celsius came. But what is this funny scale Fahrenheit? Fahrenheit came before this. And then people were thinking, Okay, what is a standard upper temperature? Then people recognize that human beings, wherever they are, they have same temperature. As someone says, 37 degrees Celsius, and then 99 or 98 Fahrenheit. So for Fahrenheit, the upper was human. The upper was human temperature, body temperature. Body temperature. And now what about the lower? Then at that time, people said, how low a temperature can we go? Have you seen people making kulfi?
Yes.
Is there anyone who doesn't like kulfi? Why? So when you make kulfi, you have little metal cups and you pour the material inside,
Yes.
and then you have to freeze it. Now remember, we don't have a refrigerator, but we have to go bring the temperature below ice temperature. So people use salt. You know, if you add salt and ice, the temperature can go very low. And at that time, when Fahrenheit scale was being organized, the lowest temperature that humans could go to is minus 32 degree Celsius. So that minus 32 Celsius became the low point, okay? So this is ice plus salt. So ice plus salt is about minus 32 degrees Celsius, and human is about 97, right? 97, 98. But to be at that time, measurement was not very clear, not so precise. So people said this is 100. So 100 degree Fahrenheit is equal to 37 degree Celsius, and 0 degree Fahrenheit, because we call this 0, is equal to 32 degree Celsius, and then you break it up. So what I'm trying to say by this example, what I wanted to say is that when it started, nothing was there. Somebody did something. So that is how we use thermometer. And unfortunately, because 2 scales have been done, you have to memorize some formula how to do it. But it's unfortunate that we have 2 different systems. What I'm going to do is, I'm going to show you a magic. And I need an assistant. Come. Introduce yourself.
My name is Akash Gorai, sir.
Hello Akash Gorai, I am Gautam Basu, and together we're going to do a magic. And then we'll explain why this is not a magic, and we'll try to explain how heat and temperature, the boring stuff that we were talking about, is part of this. Come on this side.
Magic will explain, not a magic. How is possible?
Okay, so here is a beaker.
Interesting.
Can you pour some water, little bit? So Akash is pouring little water. Pass. Keep it down. No, don't put it back. Next, I will ask Akash to take a piece of paper and ask Akash to hold the paper in a tongue like this. Can we have that fan off? Hold it. So Akash, just hold it. Do nothing. So what is Akash doing? Holding a
Paper.
What am I going to do? This is a matchbox. I'm going to, I don't know if it will burn. In science, you don't predict. You actually do the experiment. It may not burn. Who knows? I'll touch flame on the paper and we'll see what we see. I don't know what we will see because in science it should be open-minded, okay? Akash, are you nervous? Are you overconfident?
No.
Thank you. It burns. Put it down. Put it down. Okay. Now I am going to ask, so it happened what we expected. Sure. Now I am going to ask Akash to take another piece of paper. Hold it. Now wet it in water.
Not burn, sir. It will not burn.
Now if I try to burn it, will it burn?
No. It
You don't know. You expect it won't burn. But
expect it. It will not burn. It may not burn. It may not burn.
nothing is happening. Okay. এটাকে আপাতত নিচে রাখো। হ্যাঁ নিচে পা দিয়ে রেখো। I have another bottle of thing of water. And what I'm going to do is I'm going to put it in this water. Hold it with your. So this is wet, right? I put it in this water.
It will burn.
What will burn? What do you expect?
It will burn.
It will burn.
What will burn? Will the paper burn? Will the paper not burn? Will the paper burn? Let's watch.
It will not burn.
There is some flame here, right?
Yes.
Yes or no? It's not burning. Let's do once more. But there is flame here. Okay, hold it. Ready? Good. So I can see flame on the paper.
Yes.
But the paper is not burning. With water, there was no flame. Paper is not burning. Okay. Now you hold the paper. Is it hot or cold?
Hot.
But not very hot.
Very hot, sir.
So what has happened here? And that is what I will explain. Okay? Thank you.
Sanitizer, sir.
Okay?
This is sanitizer.
This is not sanitizer. It smells like sanitizer. So this is what is called latent heat of vaporization. In summer, do we sweat? Yes? Why do we sweat? To get. What is the advantage of sweating? Why do? How? How? I mean, I want to know the mechanism. Yes, you're correct. By sweating, we reduce body temperature. But how? Can I have the fans, please?
Like condensers.
Anybody here took an injection?
Yes.
Yes.
Before injection, they clean your arm like this?
Yes.
And do you feel cold?
Yes.
Why? Some liquid, spirit is put on here and it evaporates. And as it evaporates, it takes heat from your body. So when you sweat, and after sweating, if you come under a fan that is moving, then you feel really cold. Why? Because the water that comes out does not cool you down. Only when the water evaporates under a fan, then the water takes heat from your body.
Yes.
That is called latent heat of vaporization. Do you know latent heat? Have you heard of this name, latent heat? So same thing, I have here isopropanol and water mixed half and half. In fact, the isopropanol has decreased, that's why it was not so spectacular. So isopropanol and water mixed. So when I put fire here, isopropanol evaporates and it takes a little bit of flame and it takes heat from the water. So the water becomes cold and the cold water makes sure that the paper never catches fire. Whereas if it is only water, so maybe if I put little bit more isopropanol, it will look more spectacular. I don't know, let's see. Maybe some isopropanol had. So I take, I need you, no. So this is water and isopropanol. Hold it from here. Okay. Okay. Let's see. Okay, it's burning.
Yes.
The isopropanol is going. Isopropanol is going.
It's flame, sir.
Isopropanol is gone. Only water is left. That's it. Is it hot? Not really. So this is more spectacular, right? This you never expected. That this, you know, so this is more spectacular. So when there are magicians, you know, they say, oh, I have a paper, I put it in water, nothing happens. I put it in water with a mantra, boom, bam, boom, bam, boom, bam. Look, it's catching fire. But the paper never catches fire. And then you touch the paper, it's cold. But now you know why. Why was it not so spectacular before? Because I had taught class 7 this in the morning. I had made half and half isopropanol here, half isopropanol, half water. But isopropanol can evaporate very quickly. So it really evaporated. So it became more water, less isopropanol. So this is the latent heat of vaporization. So we are talking about heat. Right. It's isopropanol. It's used in, as he said, in, you said isopropanol is used in sanitizer. Now using too much sanitizer is not a good idea.
Yes.
Nowadays people have gone crazy. But it's best to wash your hands with soap. The second thing I'm going to show you today is the heat of dissolution. Say, what is common salt in
NaCl.
NaCl? Have you ever dissolved common salt in water?
Yes.
Is there anything special? Okay. I need one of you on the back to be my helper. Come. You choose, two of you are. Okay. So, I have, this is called sodium hydroxide. Do you know sodium hydroxide?
Yes. NaOH.
Yesterday we saw that some of you take sodium, put it in water, and you claimed it is sodium hydroxide. Yes. Now, this is actually pure sodium hydroxide, solid. We are going to dissolve it in H2O. Now this is a very corrosive material. So what we will do is we will take some water. Where is the water? Take some water. Can you pour water here this much? This much. Best. So there is some water, and I am going to add. Do you know how to make a solution like this? Okay. Hold it. I am going to take sodium hydroxide, and it has pellets. Okay, come. I put one. We'll put one more. Here. I'll put one more. Okay. So now we are dissolving it, okay? Dissolving it. Dissolving it. Dissolving it. This is getting hot.
Yes.
So sodium hydroxide, if you dissolve, it gets koro. Is it hot or cold? Just go on doing it. Go on doing it. Is it hot or cold? It's getting hot. My God. Can you go around and let your friends feel it if they want to? So this is very interesting. We are creating heat, not by fire, but by
Sodium hydroxide.
a salt, sodium hydroxide, or a base that is getting dissolved in water. We will talk about why later, but the point is there is heat of dissolution. Now you think all salts will give up heat? Have you heard the name exothermic? So is it exothermic or endothermic? Exo means what? So the system is giving heat out to the surrounding. You are on the surrounding, you can feel the heat. Sodium chloride almost will be nothing. Now we take another salt. Did you show your teacher? Come on. Now can you show this ma'am? Come on, now you hold this. Again, fill some water here. Okay. Maybe now you come, because you also raised your hand. Is that okay? So I have another salt here. This is called potassium nitrate. I am going to dissolve potassium nitrate and see what happens. Come. Right, KNO3. Hold it. Dissolve it. Now she is dissolving potassium nitrate. Before we did sodium hydroxide and the test tube became hot. Dissolve it. Jode. No, I'm going to. Close your eyes. I'll touch it on your chin. Close your eyes.
Yes.
We were so hot.
Cold.
Sir, sir, what?
Hold it. It's cold. Show it to ma'am and then show it to everyone else. This is incredible, right? One salt I dissolve, the test tube becomes hot.
Yes.
Another salt I dissolve, the test tube becomes cold. So is this process endothermic or exothermic? Still cold. Wait. Anyway, so so what is happening? Why is some reaction giving heat and why are some reaction taking heat from outside? And this is not chemical reaction. This is even simple. A solid breaking up into a solution. So I will try to explain a little bit and see if you can understand and then take a check. Yeah. You see, in nature, any system wants to go down in energy. No system naturally wants to become very excited, right? I mean, if you, I know you're an excited kid, but if you are excited all the time, it's too much. You also have to calm down.
Yes.
So the natural tendency is to go down in energy. So if I go down in energy, then I'll give my heat, extra heat outside. So exothermic is most natural. But if I'm taking heat from outside, what is happening? So what happens when there is crystal? So when you have a crystal, let us say, suppose I just have it drawing one lattice.
Cube.
So in a crystal, for example, where is it? Say blue is negative, orange is positive, orange, blue, and it goes like that. Blue, orange, orange, blue. So this is one, and then one more like this. So they are very happy because this is positive here and this is negative. So positive and negative are very happy close to each other in crystal. Now if you put it in water, remember water is OH and this oxygen is slightly negative and this hydrogen is slightly positive. So when water goes there, this water molecule goes to this guy. This is negative and this side of water is positive. So a water molecule goes like this. Say, look, come out, I'll give you the positive charge. Ignore him. Another water molecule comes. Another water molecule comes. So what happens is this negative ion slowly leaves the crystal and it is surrounded by water. Which side of the water? The positive side of the water. Which side is the positive side of the water? The side that has two hydrogens, because hydrogen is electropositive and oxygen is electronegative. Have you learned electronegative, electropositive? Huh? No, it doesn't matter. Okay. So once this negative ion goes, then this positive ion will come out. Then everybody is surrounded by water. Now, so there are two energies here, okay? One is energy for breaking crystal. For breaking, X means just breaking the crystal. You need energy. This energy is normally an unhappy energy because it's unhappy if you break something that is so stable. And then you have an energy of solvation, energy of water. That means when water comes and surrounds it, there is another energy, and that energy is a happy energy. Normally what happens, the happy energy is more than unhappy energy, so it happens. And that is what is exothermic. But when it is endothermic, then you need more, so then it becomes different. So the reason why some are exothermic and some are endothermic and still the reaction works is a concept called entropy. You have not heard of it. You will be happy to know that in physics and in chemistry, there is a subject called thermodynamics, which your teachers may know. Yes? And thermodynamics?
Sir, I am not teacher of science.
Okay. You are a teacher of science? Okay. So thermodynamics says that if you want to do something perfectly, you can never do it. There always will be imperfection. And this imperfection is chaos, disorder. All of you, some of you stay in your rooms, in a hostel.
Yes, sir.
Some of you, you go, it's very easy to take off your pant and just keep it there. I know, because that is the law of thermodynamics. Now, if you want to really take off your pant or shirt or bed, you have to fold it, keep it in some place, clean your room. What I'm trying to say is, if you want to bring order in your room, you have to spend energy. So the natural thing is disorder. Disorder is natural. That is what is the second law of thermodynamics says, and it's a very important law. And what I mean is, in addition to this energy, the crystal, which is ordered, like in school, go in one line, don't talk, sit down. You guys are like crystal.
Yes.
Everybody is stuck, follow rules. When the school finishes, you're running away. Not you, everybody. And so then what happens is, the moment these come out in water, then each of them can move any way they want to. There is no order. That is a happy state. So in addition to this energy, there is also entropy called by S. And it is the S that compensates and makes it go. This is a little higher concept. This is not a concept that you learn now, because if you were taught that disorder is as important as order, then you will become all disordered, which is not a good idea. We need to control you, right? Or do you think you're grown up enough to take responsibility? What do you think? Class 8, 9, 10, so this is a transition period. But this is the main thing. Have you heard of calorie? You memorized some definition? You did not study calorie yet? Say it again. Didn't you study calorie in school? In class 7? You? 1 calorie is the amount of heat required to increase the temperature of 1 gram of water by 1 degree Celsius. 1 calorie. Didn't you memorize this? Forgot. So what do you see? You have learned so many things. Yeah, I know. You memorize. 1 calorie is the amount of heat required to, like, just like, you memorize, I memorize, exam comes, I write down in the exam, after I stand first, I forget everything. Yes or no? That's why it is good idea to learn less, but learn it by hands-on. So, I wanted to talk about a calorimeter. How do you measure heat? But I will not do it. If I come back again here, I'm going to leave tomorrow. We are going to build calorimeters ourselves. Not just I show you. 5 of you do one, 5 of you do one. And we are going to, when will I do it? Whenever I come back again. I am leaving tomorrow. And that experiment will be whole day experiment. I live on planet Earth.
Sir, which country? India.
India.
No.
West Bengal.
Which
Kolkata.
Which city?
Kolkata.
District?
This Kolkata is north 24 Parganas. No, Kolkata is separate. Actually, I stay in Bidhan Nagar, Salt Lake, which is north 24. Salt Lake Stadium. Yes. Do you know why is it called Salt Lake? Yes. There used to be a lake there, and that lake was salty. And why? Not lake, but marshy area. This much water, this much water. Because, do you know in West Bengal, the south of West Bengal, there are forests. What forests are they called? Sundarban. Have you ever, anybody has seen ocean?
Yes.
Is the water salty?
Yes.
So salty water from the ocean comes up the river. Have you ever seen Damodar? I'm used to Ganga or Ganges or Bhagirathi in Kolkata. Do you know in Bhagirathi in Kolkata, 2 times a day, water flows from south to north. And 2 times a day, water flows from north to south. How? It's a good question. Tide. If you have seen an ocean, the ocean has high tide and low tide. When there is high tide in ocean, then the water from ocean goes inside the river. Because Calcutta is close to the ocean, water goes. So you can see, in Bangla this is called Ban Asche. You can actually see river water coming. Okay. So that low-lying area, long time ago, such salty water came from the ocean and that became a marshy area. It was called Salt Lake. And then it was covered with mud and other material to build a new township because Kolkata needed more places. That's so the word Salt Lake actually has a meaning. All words have some meaning. For example, Kolkata has a station called Shialda station. Some of you had heard. So what is the origin of Shialda? It's called Shialdaho. What does Daho means? Daho means large water body. And Shial means fox. So there was a large water body there where there used to be many foxes. Hey, kothay jacchi Shialdaho? Can you name one place here interesting whose name you know? The origin? Like for example, Sitarampur, Bolarampur, Kashipur. So you have to think. Raniganj. ওখানে কি রানী থাকতো? থাকতো না. What I'm saying is, if you are doing science, it is not just physics, chemistry, mathematics. You have to open your mind. Science is not magic and this and that. Science is a way of thinking. So it's a good idea to ask questions and get answer. And nowadays, many answers to many questions you will get from if you have access to a phone. I'm sure you don't have a phone, but your parents have a phone. These are incredible. It's very easy to use this and very easy to abuse this. I think I'm going to stop here. There's no point doing too much, but I'll be happy if you have any question. If you ask me, I'll try to answer. So at some point I'll come and we'll do the calorimeter. Okay, we'll build it ourselves. No lecture, only doing it. Any question?
How mobile phone is abused?
How?
Mobile phone is abused.
When you play PUBG?
Minecraft.
I have many other things.
He plays Minecraft.
It's okay. I don't want to. See, he is becoming an adult. You are becoming an adult. And the best way to help him or you, not to push you, to make you responsible. That's what I'm saying. You are becoming an adult. Take responsibility. That's all. Nobody can stop you. You are also becoming an adult. We all here are becoming an adult. So we need to learn to take responsibility. Any other question? Okay. So thank you very much for listening to me. I hope I showed you something new. I hope I tried to, excite you into thinking something. I did the same class with class 7, but I can see class 8 is more mature, which is very good. Similarly, class 9 will be more mature. I mean, that's how it happens. It becomes more and more mature. Thank you.